So where we left off, we were talking about heat capacity and changes in temperature as it relates to water as a substance. This map sort of illustrates a point we're going to be trying to get to. This is a map of Europe with point A being in London and point B being in Kazakhstan. And if we draw a line, you can actually see that these guys are basically at the same latitude. They're about at 51 degrees north, which is actually a little farther north than we are. You probably remember from some earth science you had in middle school or just something you've picked up that one of the leading, most powerful forces on climate is distance from the equator. The farther north or south you go from the equator, generally it's cooler. The closer you are to the equator, generally it's warmer. What we see when we're looking at this chart is the temperatures. There is a significant difference between the average low temperature in London, which is only about 45 degrees, not even freezing, and the average low temperature in Kazakhstan, which is 29 degrees, which is below freezing. And that's why if you went to visit these countries, you'd find that England is very rainy and Kazakhstan has a lot more snow. But they're at about the same latitude. And why is this? So if they're at the same latitude, and that usually controls climate, we have to look at what's different between them. And if you look at the area surrounding the United Kingdom, England, and the area surrounding Kazakhstan, it should jump out at you that Kazakhstan is almost entirely surrounded by land, while the United Kingdom is surrounded by a large amount of water and some land. This goes to show you that the ocean has one of the largest effects on climate on this planet. We're going to get into the specifics about this with current, but we're going to talk about it a little bit here. The ocean moderates coastal regions. It just does. And this is because water has a high heat capacity, another vocab word. We talked about this already, but what heat capacity is the ability on a molecular level for a molecule to absorb a large amount of heat without changing temperature particularly much. And you can see here they're talking about two areas, again, similar latitudes, in California. And this is figure 5-6 in the book, if you want to look at it close up, that are basically at the same latitude. And the range at the coastal area is only about 13 degrees difference between the high and the low, whereas when you go farther inland at Death Valley, the difference between the high temperature and the low temperature is about 42 degrees. So this is a much more obvious example of this. So what we want you to take away from this is that the ocean has a moderating effect on coastal temperature. You even saw that today in Sandy Hook. It was only about 85 degrees once you went out towards the beach in Sandy Hook, but as soon as you got inland, it was in the 90s, and in some places it even reached 100 today. All of this leads to a function we call the global thermostatic effect. The ocean has an effect on the globe. It just does. We'll get into this in a lot of detail when we talk about currents, but one thing we talked about already was heat capacity. Another thing we talk about is the cycles of evaporation and condensation. Remember from the diagram we made, this one, where we went like that? In here, we were talking specifically about vaporization. Well, vaporization is very similar to evaporation. These are similar processes. They take almost the same amount of energy. It's 380 for evaporation versus, 580 versus 540 or so for vaporization, calories per gram. What happens is heat is absorbed at low latitudes, preferentially. That's just because there's more heat there. It's then conducted to the upper atmosphere, the heat, because when the water evaporates and it leaves the surface, the molecules carry energy up with them to the atmosphere. Later on, all those water molecules stick together, they condensate, and then they fall as precipitation. And they release the energy that they took up with them to the atmosphere. Because the evaporation occurs at one latitude and the precipitation falls in a different latitude, and you can see this if you go look at this picture. We have evaporation latitudes and precipitation latitudes. It's one of the reasons why the temperate areas of this planet are as warm as they are, because so much energy is dropped in that area due to precipitation. This is figure 5-9 in the book, and it's one you should probably take a look at. This is a map of the globe, clearly, and what we're looking at is the difference between the temperature during the day and the temperature at night. And areas that are blue, the darker the blue, are cooler during the day and warmer at night, and areas that are red are much hotter during the day and cooler at night. So we're looking at the difference. And if you notice, there's only a few areas, mostly in this region and over here, and a little bit right here, that it's actually cooler during the day. Most places don't have that. You'll notice, though, that there are places that are hotter during the day. Oops. Let's use a pen. Tend to be at the centers of continents. As a matter of fact, they frequently coincide with deserts. There'd even be, if you zoomed in, a very small one in the middle of our country, and the Andes in South America. These places tend to be much, much hotter during the day. This is because the ocean, they don't have large bodies of water, they aren't near an ocean, that doesn't provide a mitigating or moderating effect. So the land heats up and it cools off very quickly because granite basically, has a very low specific heat. If you look at the ocean itself, that's included on the map, and it's actually the very light blue. What that means is there's no difference from day to night. And that's true for 90% of the ocean, that basically it's always the same temperature. Again, another factor showing how the ocean can have a stabilizing effect on the environment. Other global thermostatic effects includes the marine effect. This is a specific term and it applies to our area. Two more vocab words for you. Marine effect and continental effect. And you can see this in the last picture. Areas with the largest difference in temperatures tend to be in the middle of continents. They have the largest temperature difference, both daily and seasonally. I should have put that on the slide. They have huge daily variations, and they frequently also have the biggest differences seasonally. The marine effect means that if you're along the coast, your daily temperatures swing the least, as well as your seasonal temperatures. Places along the coast tend to have more mild seasons than elsewhere. And that's where we're going to stop for this one. Not very long. And I'll see you guys in class.